Hey everyone, welcome back. So today, we're diving straight into this explainer to uncover something pretty wild: how the somewhat dry science of matter actually functions as the ultimate everyday recipe book for our entire universe. We're going to look really closely at the very building blocks of the things you touch, taste, and breathe every single day. We've got a fantastic roadmap today. We're going to cover the world of mixtures, uniform versus non-uniform substances, the magic of alloys, the secrets hiding in the air we breathe, and finally, what it actually means to be a pure substance. Let's get to it. Part 1, the world of mixtures, looking at everyday matter. Take a second right now and just look around you. Like, really look. What is your world actually made of? Check out your lunchbox, the clothes you've got on, maybe the staircase you took this morning to get to work or school. We usually think of these things as just one thing, right? A shirt, a stair, a meal. But honestly, almost nothing around us is made of just one single isolated substance. It's kind of mind-blowing when you think about it. Take a bowl of poha, for example. It's a fantastic, delicious everyday dish. But scientifically speaking, whether you're looking at that bowl of poha with its peanuts, herbs, and flattened rice, or even just a simple glass of sugar dissolved in water, you're looking at a mixture. The rule here is simple. When two or more substances mix together, but each one keeps its own individual properties without actually chemically reacting, boom, you've got a mixture. Moving right along to part 2, uniform versus non-uniform, the types of mixtures. All right, let's contrast a healthy, crunchy sprout salad with a glass of sugar water. In the salad, it's obvious, right? You can easily spot the green graham, the chickpeas, the chopped onions, and the tomatoes. But the sugar water, that looks completely clear. It looks exactly like a regular plain glass of water. And this visual difference brings us to a formal scientific definition. That sprout salad, that is what we call a non-uniform mixture. Basically, you can see the different components with your naked eye. You could physically sit there and pick the ingredients apart if you wanted to. The pieces just don't blend into a single visual mass. On the flip side, that clear glass of sugar water is a uniform mixture. It's uniform because the sugar and water particles are distributed so perfectly and so evenly that you literally cannot tell them apart. You couldn't see the separate components even if you were staring through a super powerful microscope. It just appears as one continuous, consistent substance. Which brings us to section 3, the magic of alloys, solid mixtures. Now here's where it gets really cool. Uniform mixtures aren't just limited to liquids like our sugar water. They can actually be solid metals too. You might not realize it, but those stainless steel plates and bowls sitting in your kitchen cabinet, they aren't made of a single element on the periodic table called stainless steel. Actually, they're incredibly complex, uniform mixtures made of iron, nickel, chromium, and a little dash of carbon. They melt these metals down and blend them so perfectly that when they cool, they look like one single shiny piece of metal. Science actually has a specific name for this chemical magic: an alloy. So an alloy is really just a uniform solid mixture of two or more substances, usually metals, where you can't see the individual components. Besides stainless steel, you've got brass, which is a mix of copper and zinc, and bronze, which is copper and tin. They are absolutely perfect examples of this. Oh, and I absolutely love sharing this quick historical twist. This is definitely not just modern science. Ancient Indian texts like the Charaka Samhita totally recognized these incredible mixtures and called them Mishra-loha. They figured out that mixing 4 parts copper and 1 part tin created bronze. And get this, they actually used these specific alloys to help boost digestion and improve immunity. How cool is that? Just a brilliant example of ancient wisdom using the science of mixtures. Part 4. Secrets in the air, invisible mixtures. So let this sink in for a second. The very air you're breathing right now is a highly complex, uniform mixture. It's mostly nitrogen, about 78%, which, fun fact, doesn't even aid in combustion. Then we have oxygen, absolutely crucial for us to stay alive, plus it's what makes things burn. Throw in some argon, carbon dioxide, and water vapor. It all mixes together so perfectly that we literally walk right through it all day, totally oblivious to its individual parts. Okay, let's do a little detective work and prove that this invisible mixture actually exists. We're going to test for carbon dioxide. First, we take some calcium oxide, you might know it as quicklime, and mix it with water to create calcium hydroxide. We give it a good stir, filter it out, and what we're left with is a totally clear liquid called lime water. Next, we just pour this clear solution into a little petri dish and leave it sitting out in the open air for a few hours. And here is the magic. When that clear lime water is exposed to the air for a while, the carbon dioxide hiding in our atmospheric mixture reacts with the calcium hydroxide. This reaction creates these tiny, insoluble white particles called calcium carbonate, which turns the whole liquid milky white. It is just a perfect, undeniable visual clue, proving there's an invisible gas right there in the room with you. But hey, gases aren't the only secrets hiding in the air. Let's do one more super quick, easy experiment. Literally all you need is a clean, entirely black sheet of paper. Just make sure there's absolutely no dust on it to start. Leave it undisturbed near an open window or maybe out in your garden for a few hours. Then go grab a magnifying glass and take a really close look at the surface. What you'll see perfectly illustrates how suspended pollutants work. That once clean paper quickly collects all these tiny little dust particles, what we call particulate matter. Now, these aren't a natural, integral part of the air's actual gas mixture, but they are solid pollutants suspended right inside it. It just goes to show how dynamic and packed full of different matter our air really is. So when you put all these examples together, you get this truly fascinating matrix of mixtures. Matter is just endlessly combinable. I mean, mix gas and liquid, you get a fizzy soda. Mix solid and gas, you get airborne pollutants. Mixing metals gives us alloys. You can mix liquids with liquids, like oil and water, or solids and liquids, like sand and water. It beautifully shows just how incredibly diverse and mixable the matter in our universe really is. Which brings us to Section 5, defining pure substances, the purest form. In science, the whole reason we often want to separate the components of a mixture in the first place is to get right down to the basics. Like, when we strip away all the mixed-in parts, what are we actually left with? Well, we're left with a pure substance. A pure substance is a kind of matter that simply cannot be separated into any other kinds of matter by physical processes. So when a scientist says something is pure, they mean it consists of only one single identical type of particle all the way through. It's basically the fundamental ingredient before the recipe even begins. So as we wrap up today's explainer, I want to leave you with a bit of a challenge. The next time you sit down to eat, I want you to take a hard look at your meal, your drink, maybe even the metal fork in your hand. Ask yourself, what kind of mixture are you actually about to consume or use? Is it uniform? Is it non-uniform? I challenge you to look at your world entirely through the lens of these everyday recipes of matter from now on. Thanks so much for exploring with me today, and keep questioning the world around you.